Hello, pre-cal. We are going to work through some problems together today. We're going to be working on worksheet 6.8b, which is page 55 in your packet. It's on principal values of inverse trig functions. And it looks like this. Let me move this out of the way. So, we've actually done problems like this before, but we haven't focused solely on the principal values. And the way that we know that we're dealing just with principal values, remember, are these capital letters. So this says arc sine equals -1. So this value actually represents an angle. And what we're going to do is you can do this a couple ways, but we're going to take the sine of each side. Because what that does is it gives us the equation, and I'm going to flip this around because I always like to flip it around, that the sine of theta equals -1. And remember, with the principal values, I want you to draw this little coordinate plane over here with the part of the unit circle that applies to the principal values of sine. So hopefully you'll remember that that goes from -π/2 to π/2. So we are looking for the angle that gives us a sine of -1 within this domain. So of course, we know that sine is the height, and we're looking at theta equals -π/2. That is the angle within the given domain that gives us a arc sine of -1. Okay, so hopefully that made sense. And now we're going to go ahead to number 2. So number 2, we're dealing with cosine. We start the same way, and we're going to take the cosine of each side because we know that taking the cosine of the arc cosine, they cancel each other out. And so what we're left with is the capital C cosine of theta equals 1. And again, we have a certain domain, a limited domain, when we are dealing with the principal values of cosine. And that goes from 0 pi to pi. So we're looking just here on this half of the unit circle to see where the cosine equals 1. So hopefully you remember cosine is the x values, and only at theta equals 0 does the cosine equal 1. I'd love for you to pause this video right now and see if you can do number 3, arctan of -1. Okay, then come back and I'll work through it with you. Okay, let's see how you did. So hopefully you set this equal to theta and took the capital T tangent of each side. Again, we are just focused on the principal values. So we're looking for when the tangent of theta equals -1 on a restricted domain that goes from -π/2 to π/2 and doesn't include -π/2 and π/2. So this is what we're looking at. Opposite over adjacent equal -1. So that must mean that theta equals -π/4, which, by the way, is -45 degrees, in case you were wanting to practice your conversions from radians to degrees. Okay, so far so good. Okay, so on the next problems, we're really just doing the same thing. So you're going to set each one of these equal to theta, okay, because they all say inverse, cosine, sine, or tan, basically. Set each of them equal to theta, and go ahead and see if you can solve these on the restricted domain. Stop the video, and then come back after you've done these 3, and let's see how you did. Okay, let's take a look. I set some things up already. I wanted to give the little graph of the domain, and we know that, for example, in number 4, we're going to take the cosine of each side And you should have gotten the equation cosine of theta equals 1/2. And remember, I've been telling you for a long time, memorize those values on the unit circle, because now you should know that the cosine of 1/2 equals, or the cosine of theta equals 1/2 only when theta equals pi over 3, which, by the way, is 60 degrees. So that would be the triangle that looks something like this. Okay, here we go. We've got the sine of theta for number 5 equals 1. So we're basically asking, where is the height in the unit circle equal to 1? Well, that is vertical right there. So theta equals pi over 2, which is 90 degrees. You might be asking, do I want both answers? I think it's really helpful for you to have both answers, just for you to practice. And by the way, if I had to tell you which one I would want, if I had to pick, go with radians, because I'd rather you practice that. Okay, number 6, we cross out tangent and inverse tan. So what we have is, where is the tangent of theta equal to negative root 3 over 3? And again, this all goes right back to the unit circle. Theta equals negative pi over 6. In other words, negative 30 degrees. Okay? So if you had trouble with those, what you might want to do is go back and redo them. Okay? Definitely draw the domains and see what you can do there. Let's move on to the next type of problem. So, as you recall, the way we just solved the problems was that we took the cosine of each side so that we could cross out inverse cosine. So that's basically what we can do here. This is restricted to one particular angle. We wind up with an answer of negative 1/2. Those values just cross each other out. They cancel, they're inverses. Same thing here. They are inverses, so we get negative root 3 over 2. And look at this one right here. Tangent of inverse tan, root 3 over 3. Those are simple, aren't they? Okay, same thing for number 10, but now this time, okay, we have the inverse cosine on the outside and the cosine on the inside. That's okay. They still cancel each other out. They're still inverses. Number 11, easy peasy. Cross those two out. The inverse sign and the sine cancel each other, so we just get pi over 4. Well, number 12 is not that easy, because notice we have the sine of the arc cosine of root 3 over 2. Recall that this is basically the kind of problem that we solved on 1 through 6. So what we will do is we will set the arc cosine of root 3 over 2 equal to theta, because that all represents an angle. And you will take the cosine of each side so that we can take the inverse of that and get rid of it. And we're left with the capital C cosine of theta equal to root 3 over 2. So you should be thinking to yourself, okay, I am on a restricted domain from 0 to pi. And where is the cosine of theta equal to root 3 over 2? Well, that would be in the 30-degree angle. Okay, so the cosine of theta equals pi over 6, which, as I just said, is a 30-degree angle. Now, that's not the answer. That is the value inside the parentheses. So essentially, we are asking for you, you're going to substitute that in. We're asking, what is the sine of pi over 6? I really hope you know that one, because the height at pi over 6 is 1/2, and that is your final answer. Again, if you had trouble with any of these, I would go back, redo them. You can do them a few times to make sure you've got the process. Okay? Have a great day.